Hello everybody, this is our video on how to flock saltwater algae, particularly the breed Nannochloropsis oceana, if I have that right. That's the one I thought I bought, although I think this works for all the Nannochloropsis species because they're basically the same thing. They all live in the same kind of water, I think. I don't know much about that. All I know is that you can do cool stuff after you isolate the algae from the solution, like make fuel, make protein powder, uh, cosmetics if you're stupid. So basically, I'm gonna give you a little bit of rundown on the science behind this, how this works. Okay, so basically, we have this molecule called chitin. Okay. This is the stuff you learn in biology. It's found in crabs or whatever. You know that the one question on the test where you're like, it's like polysaccharides. What's a polysaccharide? Oh yeah, crab shells. Okay. So basically, chitosan is not chitin. It's basically just a deacylated version of chitin. So chitosan is basically just you take the acetyl, you take that acetyl, and what you're left with, you're left with some amines. Actually, well, technically, I mean, you're amide to amine. What does it matter? I took Orgo too. I'm cool like that. So basically, you have NH, you just have a positively charged cation. That's basically how it works. And essentially, it makes sense that this is dissolvable in acid. And I wrote equals this thing right here because you're going to see how exactly this works with different types of algae. So basically, all you got to know, it's a version of chitin, or it's derived from chitin at least, and has multiple beneficial effects. I don't really know all of them. All I know is that it does cool stuff with algae if you work with algae. Pretty much it. Dissolves in acid. You need an acid to dissolve this, or else you're going to have a really bad time. It does not dissolve in water because why would it? Okay, so basically, freshwater algae. Really freaking simple to flock freshwater algae because freshwater algae, it's normal. It's chill. It doesn't really think that much. It doesn't require that much input because the solution that it's present in is not really that ionic. It doesn't have that much ions, or it does have a lot of ions, but you get what I'm saying compared to saltwater algae. So basically, when it's in its protonated form, chitosan forms this kind of positively charged shell around the algae. And the reason it's able to do that is because, as you know from biology, that phospholipid membranes, they're negatively charged on the outside. They have the polar heads, the phospholipids, blah, 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 blah. So basically you have a bunch of negative charges around the membrane, and the chitosan's able to bind around it and form somewhat of it's kind of like a cage, but it's able to basically clump the algae together in solution. You're able to isolate it much easier than you would, say, single cellularly. Whatever it is. Doesn't really matter. So now we get to saltwater algae. And this stuff, these guys hate you. These guys hate you very much. You know why they hate you? Because they live in a crappy ass environment. You know why? Because they have calcium chloride. They got calcium chloride, sodium chloride. You get the point. They have a bunch of ions in the solution. And that makes it kind of hard for the chitosan to act because, it's an ion itself. When you add an ion to a kind of non-ionic solution, the ion's going to do something. If you add an ion to a solution that's already ionic, it's not going to do anything because it's just another ion in the solution. You get what I'm saying? So basically, also, I wrote all these ions down real quick just because this is like the fake saltwater solution I usually use for the Nannochloropsis that I use, or Nannochloropsis I grow. So mostly I use just, you get the point. I use calcium, sodium chloride, magnesium sulfate. It works well. I mean, you can see it grew pretty well. It's overgrown at this point because I'm a lazy loser. Okay, so basically you dissolve this in some sort of acid. I will get to that in a bit because I'll show you what acid I dissolved in. So you dissolve it in acid, you add it to the solution, it flocks freshwater algae. With the saltwater algae, you add it to the solution, it lowers the pH of the overall solution. So pH like 4 to 6, it's not going to do crap. You know why it's not going to do crap? Because, like I said, another ion. So if you get it to a pH, or if you raise the pH with some sort of base, what ends up happening is these end up getting deprotonated, and you end up with a neutral molecule. You end up with a neutral version of chitosan with, Not the positive charges. You get the point. You get the point. So basically, without these positive charges, you get a nonpolar molecule. And because the chitosan has already been dissolved in the solution, it ends up forming a nonpolar cage around a lot of the algae. So you get the whole point. Whoever is taking biochemistry kind of knows the whole idea of, like, why things sort of form this way, because there's water all surrounding it, there's a bunch of ions, so nonpolar substances are going to want to like clump up together with itself, and in doing so it ends up trapping the algae as well, because in addition, like, this may have some sort of effect. There's a bunch of papers. There's actually like only 2 papers on this, but it works. It works pretty well. But yeah, that's basically how you're able to flock algae. You lower the pH of the overall solution with chitosan dissolved within that solution, and then you heighten the pH and creates non-polar cage to trap these freaking jerks. Once you like get off some of the, or at least I call it's not really a super neat, some of the excess solution at the top that doesn't have any algae flocks within it, just like add it, and yeah, you end up getting pretty meaty solution. And then any of the algae that ends up getting, I actually have 3 filters with this thing because I don't have filters that are that small to catch single cells. So there will be still some cells that like get to the bottom, but usually because the solution is already, I actually don't even know why it flocks at the bottom. I have no good explanation for why it does, but usually like afterwards, what I end up doing is I just like I pour off whatever is like here, and then I end up like re-putting it up here. But I have gotten some pretty good flocking efficiency where this is almost just completely clean, and I had no problem whatsoever. So yeah, that's pretty much it for the experimentation.